supposed to know what that is, right? So this is January 2022. Let's go. This is a trapezium, 2 parallel sides. Okay. We go in rhombus. A rhombus is a shape where all 4 sides are equal, right? But it's not a square. Okay. So this is your rhombus. Gosh, I have a new student coming. Right, so this here is your kite. Right. Which one of these have no line of symmetry? You all know what symmetry means? It cuts it in half, right? Which one of them? Trapezium. Food. That's food. So we put it in trapezium here, right? Trapezium, right? Right. So if something has exactly 2 lines of symmetry and 4 right angles, which one of these here? Remember, it's these rectangle. Exactly 2 lines of symmetry. You all know what a line of symmetry is, right? It cutting it in half so that when you fold it, it will be the same thing, right? So that will be a rectangle. A rectangle, let me draw the rectangle here, right? Boom, bang, bang, bang. So look at this rectangle. You could only cut a rectangle this way and this way. You cannot cut it diagonally. But a square, you could cut a square diagonally and you could fold it in 2 and it will be the same thing, right, guys? Yeah? Okay? Right. So I'm moving these things here. Right. So that will be a rectangle. Right. So you all had this already, assuming. Right. So I want to give you all a note on rotational symmetry, right? Right. Okay, red. Right, so rotational symmetry, 2 M's. Right, so rotational symmetry, you'll try to write same speed with me, right? So you wouldn't have to wait, right? Rotational symmetry occurs when a shape looks exactly the same after being turned. Right? Which, when I say turn, right? When I say the word turn, you all know I mean the word rotated, right? Yes. So I just put that in brackets here. So turn rotated about its center of rotation. Right? So which one of these up here has 1 line of symmetry but no rotational symmetry? Meaning that if I rotate it, it would look the same like how it is. Right? It has 1 line of symmetry, but this is easy. Kite. Right? If you put the kite in the middle, bow. Right? Same thing on either side when I fold it, right? But if I turn that kite 90 degrees, would it look the same? No. If I turn that kite 180, would it look the same? If I turn it 270, would it look the same? So there's no rotational symmetry. Y'all see there? No rotational symmetry. All right. The student probably I tell them when they reach my extra. I'm just on pause. x prime, y prime, z prime, and x double prime, y double prime, z double prime, right? Drawn on a square grid. So everybody see the square grid here. Okay, everybody was able to recreate it. All your graph paper, girls who now come in. We boy. Graph book can't keep here, boy. Anybody had to lend them? All you had to give these brothers back some book next week, some graph paper. Right, that graph book got done. Right, so we go in. 1 centimeter to 1 unit is the axis on both, well, the scale on both axes, right? So everybody should have this. I just want to clearly indicate what my coordinates are here. What's the coordinate of x prime here? Let me see. What are the coordinates of x prime? Anybody? Online, you all also. -3 on the x-axis and 7 on the y, right? Everybody's able to see that?
Yeah.
This coordinate here, right? This coordinate here is -3, 7, right? This coordinate here, what is this one here? -1 on the x-axis and what on the y? 7. Right? What are the coordinates of z prime? That's this point here.
-3 on the x and 3 on the y.
Excellent. All right. Let's go to z double prime. What is this coordinate here? 7, 3. Right? What is this coordinate here? We just listen the coordinates so everybody still drawing, right? What are the coordinates of this point here?
7,
7. Excellent. This one here. 5 on the x and 7 on the y. Who's not able to see these coordinates? Because that's very important, eh? The girls who just came in, we now started, we didn't start too long ago. Yeah. So we have these two triangles here. Okay. This is what CXC gave you. This is January 2022 we do. So we only did the first part and this is the second part now, right? Right. So we're gonna see what CXC wants us to do. They said triangle x prime, y prime, z prime is the image of the triangle x, y, z after an enlargement of scale factor 2, right? With center 5, 1, right? So your center of rotation is actually 5, 1. We need to locate 5, 1, right? Which are the coordinates of the center of enlargement. Where would 5, 1 be? You all seen it there? You all seen 5? First things first, my first value is always my what value? On which axis? X. Everybody knew that, right? And my second value will be my y-axis value. So 5 on the x is here. Everybody agrees? And then 1 on the y is here. So I'm going to put my center of rotation here. Everybody good there? Now, how do you locate where the original triangle is when they only give you the enlargement? So this is the enlarged triangle. We have to find the original one. So we're going to draw lines to connect this center of enlargement to every single coordinate. So y'all do this to me. Hey, boy. I ain't got the... Going on here, boy. Right. By 1. So we're going from the center of enlargement to Z. That's 2. All right. Center of enlargement to X, which is up here. Okay. So do that for me now, please. All right. So we go and try to locate this triangle, right? Bro, look down now. What are you watching there? Everybody good there? Right. We have to locate this triangle, right? Now, if the original triangle enlarged to this larger triangle. Let me tell you some things that would happen, right? If the length of this line here, you're seeing the length of this line is 4 centimeters. It's 1, 2, 3, 4. The length of the original line in the original XYZ triangle, this line would be 2 centimeters. So what you could do is you look to see where between these two lines, you have two distinct points that are 2 centimeters apart. You all seen it? I seen it. See if all has seen it. So between this line and this line, see if it line up, any 2 points line up that are 2 centimeters apart. Anybody face-to-face seen it? Anybody online seen it? See if all has seen this. Go ahead, Jasmine. You had the coordinates for me? Give me the coordinates of X and Z.
So Z prime would be 1, 2.
Excellent. Excellent, Jasmine. This is not Z prime. Eh? This is the original Z.
Well, yeah.
Right? And then X would be
1, 4.
That is X. You all seen it? Enter 2 centimeters apart. Soak it in, eh? Soak it in. I'll put this on this side because I'm going to draw a line here. So this is my X. Now, from here to here is 2 centimeters apart. You all seen that? I'm going to put the arrow on it. X prime to Y prime is 2 centimeters apart, right? So the original drawing, if the enlargement scale factor is 2, it's like you have to divide 2 by 2. So the original line will be 1 centimeter. So from X to here, supposed to be 1 centimeter. So this is where my original Y would be, right? Right here. So I'm going to draw this triangle now. So we go in, I want to draw it in a different color. Join it in red. So we go in boom. Yeah. That thing come out good. So is it line up on your side? Everybody getting it to line up there? In your books. Isaiah, you get this? It line up? I'll come and I'll check it. Right, that's 2. This here is my original triangle. You get this? Of the triangle X prime, Y prime, Z prime on the grid above. We did that. Part 1 is complete, right? Roll into part 2. So triangle X prime, Y prime, Z prime is mapped onto triangle X double prime, Y double prime, Z double prime by a reflection in the P, right? Oh, it's not what I mean by in the P there. Okay, in the line, it's supposed to have in the line P. It's supposed to be in the line P, right? So state the equation of the mirror line P. So we're scrolling up. This is where we had to think, right? So look at the 2 images, which will be X prime, Y prime, Z prime, and X double prime, Y double prime, Z double prime. So they're saying it has some mirror in the middle there. Okay? Who can locate where that line is going to be for me? It's supposed to be exactly between the 2 triangles. Where that line will be. Which value of X would it be running from top to bottom through? Who could tell me? What you could do, track 1 point, right? So let's track this point. We're tracking this point. Where is the direct center of these 2 points here? The points I have highlighted in green. Who could tell me? Anybody seen it? The mirror line is going to be a line running from top to bottom directly between those 2 triangles. Okay? What line or what value of X would that line be running through? Online, Destiny, what are you thinking?
So I'm thinking like 2 by
2. Let me see 2. So Destiny said 2. So is this the mirror line here? Is a line running through 2, right? Is that the mirror line? So let's count from here to the mirror line, right? So how much space is this to be? 1, 2, 3. Is it the same distance on the side? 1, 2,
Yeah.
3. So is Destiny correct? Yes, she is. Right? Very good, Destiny. Right? So this here would be my mirror line. The equation of this line is simply x is equal to 2 because it's running through 2, where x is 2. Okay? Draw my mirror line, please. And you could put this is how we just kind of indicate it as a mirror. So, you know, a reflection. Draw my mirror line, please. Right. So we're looking at these two pentagons. So are they opposite? Is P opposite to Q? No. Is P being reflected to Q? No. Now, what does the word congruent mean? That's the definition I give you. So write this definition. Translated, right? Well, we know it's not translated because I just explained what translated mean, right? Okay? Translated means it slide. So when something slide, it would look the same. This is not looking the same. And it did not put the word rotated. So let's write what congruent mean. All right, so I write it right on it here. I don't need to write the definition of the others. All right? Because we know what the others mean, right? Okay, so two shapes are congruent if they are exactly the same size and shape, right? So are these two images exactly the same size or shape? It don't matter how they turn up. It don't matter like how you position it. Are they the same size and shape? Yes. So pentagon P is congruent to pentagon Q, right? And look, I just give you already reason as the definition. Right, Jivan? I give you the reason as the definition. So write it over. Write the reason for your choice. The reason will be because they are the same size and shape. Right? Okay, you could also put like, let me put something else, right? Instead of writing the same size and shape, you could also put that the two shapes have the same equal, well, the same sides, let's put the same sides and the same angles, meaning that all the angles on the inside are the same, right? Same sides, same angles, they are congruent, right? Everybody good here? So you'll realize they're not just asking it to just transform things, they're asking it definitions too. All right, come back here. Right, what's your triphon? I zoom in here. This here, between 2 and 4, this would be 3. Everybody good there? Between 4 and 6, what number would be here? 5, all right? So that's why I get 5, 2. It lines up with 2 on the y-axis, right? Triphon, you seen it?
Yes, sir. No understand that.
Right, and then 4 and 4. Those are the coordinates of the vertices. So we're going to enlarge this now, but I need to know that you'll have this on your page. Right? Guys, please make sure you have graph paper by tomorrow. You can get you'll get an extra food, like in our grocery. Yeah, you're supposed to get there. You just go in that section up in the back and you'll get graph paper. I'm sure some of them probably have graph book. Students always have plenty graph books too, because every year teachers ask them to buy it. Every new school too. Right. Are ready to see what CXC wants? Okay, so we're going on. On the diagram above, draw accurately each of the following transformations, right? Transformations, okay? The enlargement of letter A, BU, by, right, by, where did you come from? Okay, the enlargement of letter A by scale factor 2. So scale factor 2 means each line is enlarging by 2. You're multiplying each line by 2. Okay, about center 6, 6. So let's first locate, oh, look, CXC gave you the center here. So write down the center of enlargement here. And I'll show you all how this thing will go. So write down the center of enlargement, 6, 6. I'm going to move these coordinates, because they will come in the way of what we're about to do. Right. So when you're enlarging, this is what we have to do, okay?
So, yeah, share screen frozen.
It frozen. Right, we're back, guys. Oh, you're not supposed to get no problems online now. Okay, so are there any 2 points along these 2 lines, right? I'm highlighting them. You see this line and this line? Are there any points along these 2 lines that are 4 centimeters apart? Which 2 points? 4. Is it here and here? This off. That's not. Yeah, this point off. That's not. This is supposed to be a little more so, and this is supposed to be a little more so. Right. So you all see it there now? Still have to be a little more so. Right. So there'll be these 2 points here and here. Okay? Those 2 points are 4 centimeters apart. Now, how do we know where the top point is going? Right? Now, what is the distance from this base here to the top here? 2 centimeters also. You all see that? 1, 2. So you know the distance from the base, which will be the middle here, to the top would be 4. So you're going 1, 2, 3, 4. So you see how it is exactly here? That's how we track this enlargement. All right? So I'll put in blue. So we're going in blue. All right? So we're going from here to here. Please connect my points. Here to here. Then we coming from here to here. I ain't getting the autocorrect there, boy. Microsoft, you're wicked, boy. Right, so from here to here. Do that for me, please. Right. And the line above here would be a little, well, between these 2 points here. Between here and here. Right? So that there is my completed enlarged A. You see how excellent that looking? So let me see all now. Right? So the coordinates, watch, this coordinate here would be what? 0 on the X, -2 on the Y, right? This one here would be 4 on the X and -2 on the Y. Right? You getting through? You getting through there? You gotta get graph paper. So we go ahead. I'll come in. Let me check all of it. Faith, online, you all draw this, right? And let's go and check some papers too, right? So CXC basically wants you to take the original A and translate it. So what does that translation again? We did it in detail last week. A translation is a slide, right? Now, this is the vector that defines my slide, right? Remember from last week, if the top number means my movement left or right. If it is negative, it's moving to the left or to the right. Left, excellent, or the memory good, right? If it is positive here, the bottom number, are you moving up or are you moving down? So 3 points to the left, right? And then 2 up. So we check in 1 point. Let me check 1 point. So I'll come in here, I'm starting at this point. The vector for our translation, aka slide, is -3, 2, right? So we slide in. I start in here. I'm gonna get a different color. I'm gonna get a different color. We going in green. So we go in 1. Ishan, how your graph looking there?
I like yours.
Nice. 1, 2, 3. 3 spaces to the left. You good there? Lock in, fellas. Lock in. Very good. Man do 30. 3 spaces to the left. How much spaces up? 2. That's what this vector means. Sister, I wasn't here last week. You watch the video? All right. So I don't know if you remember what translation is. We have a vector for translation. The top number means movement to the left or to the right. If it's negative, you're moving to the left. Positive, you're moving to the right. The bottom number indicates movement up or down. If it is positive, you're moving up. If it is negative, you're moving down. So we move 3 spaces to the left. Now we're going to go 2 spaces up. So this is the top point, right? So I come in here now. I don't know how graphs has hurt my eye. Eh? No, serious. It has hurt my eye, boy. So we're going 1, 2. So we here now.
It freeze.
Wait. Well, then that's something not to do with this. Yeah, it freeze we. That cut, boy. I sure if I pause this. Right, well, tell me if it's sticking, right? Right, so there we go. State the coordinates of R. What are the coordinates of R, my children? What are the coordinates of R? 0 on the X.
3.
0, 3. Excellent. 0 on the X-axis, 3 on the Y, right? Watch it. This R here is actually in line with 3, right? Yeah. Oh. All right. So back here, this is 3. Everybody good there? So this point is 0 on the X-axis because it's in line with 0 and 3 on the Y. So I'm going to put that here. 0, 3. Everybody good there? Well, let's tell me if I don't understand. Is Isaiah? You good there? You're sure? Right. On the diagram above, draw P prime, Q prime, R prime, a reflection of P, Q, R in the line Y is equal to 1, right? Scrolling up. I'm going to draw the line Y is equal to 1. Where is 1 on the Y axis? Is it here? So to draw the line Y is equal to 1, it will be a straight line going through where Y is 1. So do that for me now, my children. So I'm going to put my little thing here to indicate that it's the image. Right? This is the line Y is equal to 1. So let me see who can reflect this here. Reflect. Right, very good. So if we reflected this triangle in the line Y is equal to 1, okay? You track each point. So this is 1 centimeter to the reflection line, so it will be 1 centimeter away. This is 2 centimeters to the reflection line, it will be 2 centimeters away. This is 1, 2, 3, 4 centimeters away from the reflection line. So it'll be 4 centimeters underneath here. 1, 2, 3, 4. So this here would be my reflection of PQR in the line y is equal to 1, right? The reason why we use in for reflection is because when you look at a mirror, you see reflection in the mirror end. So it's the same terminology. Matra, you have a question? I see your hand up. Liam.
Yes, I do.
All right, good. So we come in here now. P, we want to draw P double prime, Q double prime, R double prime, a reflection
Well,
of...
what year was this?
This is January 2018. Right? P prime is a reflection of P prime, Q prime, R prime. So reflecting this one now. In the line, X is equal to 0. Where's X equal to 0, guys? X is equal to 0 is actually a Y-axis. You all know that? I'll put that in a different line, in a different color, sorry. Put in blue. So I'm going to draw a line coming from the top to the bottom here. So we go in, boom, coming straight down. So this line here is going to be the line X is equal to 0, right? So this line here would be X is equal to 0 because it goes through where X is 0 here, right? So reflect that on the next side now. This is your mirror line here. So reflect him. Come on, reflect him. I put my little mirror things here. Boom. So we go and reflect in this mirror. Right, Isaiah? Reflect him in the mirror. So reflected through here, where the image will be. And it will be on this side. It will look like what is called a chip. Well, you see how chip does look like it open out? Or you know what's chip? You know? You know what's chip? You know what's chip? Only you? You know what's chip, Mikel? Yeah. All right. In this front row here, you know what's chip? Online. Who knows what's chip here? When I go Manzan, it has been on the show. And when you open it out, it has looked like what we go and show now. So, right. Where P double prime will be, R double prime will be right here. R double prime actually not moving. It'll be like right on the same spot. So it'll be R, the blue is R double prime, right? So how are we building it? We're building it 1, 2, and on the next side we go in 1, 2. This new point will be here. Everybody good with that? It was sleep when we done pass by dog boy. Yeah. So go and do our next point now. This will be P double prime, by the way. This is P double prime. So let me get Q double prime. 1, 2, then 1, 2 away. Q double prime. So we go in down this way and this way. Top turn. You see it look like a chip? That's the chip that you open it out. Proper thing. Hey, sister, you put in your things to show your image. Like to show this is the mirror now. Look how wonderful this picture looking now, boy. Like art. Azika, you're looking like always something with CXC. There you go. Describe fully the single transformation that could map P double prime, Q double prime, R double prime onto PQR. So they want to know what you think could map this onto this. What do you think it will be? Look at Joe de Folia. No, that's not no flip. It's one single transformation. It could actually be a rotation. You see that? It could actually be a rotation. But the rotation is how much? Where's the center of rotation? Now, when you have, it's actually a rotation of 180 degrees. When you have a rotation of 180 degrees, you just have to connect two corresponding points. Where they cross would be the center of rotation, all right? So watch it. What color to put now by green? All this bacchanal going on here. So let's join this R with this R. So I go in here to here. Let's see with me. Follow the colors. You're with me? Here to here. That's two corresponding points. Because they want to know what could move this to this, right? Then we'll go P to P prime. 2 corresponding points. Was the center of my rotation, my children? Was it coordinates to the center of my rotation? 0, 1. Tell me all the seen it, and if you're not seen it, tell me all you're not seen. Yeah, I get that from these things. So I want to write one thing here, right? So note. Put a note under this question. Note. To find the center, come on, you're right. To find the center of rotation, for a 180-degree rotation, we simply connect two corresponding points, all right, where the intersect is the center. I like how I write this. Is the center of rotation. All right. Okay. So we already found our center of rotation above. Right. So my center of rotation was, what was 0, 1. So center of rotation for this question is 0, 1. So they want you to describe fully now. Fully. Right? So the single transformation that maps triangle P double prime, Q double prime, R double prime onto PQR. Triangle PQR is a rotation of 180 degrees, right? It rotates a full 180 degrees. Now, once it's a rotation of 180 degrees, you can put clockwise or anti-clockwise, it doesn't matter, right? A rotation of 180 degrees about the center 0, 1 in a clockwise direction. Everybody good there? On pause. Triangle PQR undergoes an enlargement of scale factor 2. Calculate the area of its image, right? Now, they didn't ask us to draw it, or they realized that. They did not ask us to draw the enlargement. But if it undergoes an enlargement of scale factor 2, right? So let me just, we check in the triangle here. So if it goes up by scale factor 2, now look at something here. This is the base, right? I drawn it here. This is the base. Everybody agrees? And this will be the height, right? That is the 90-degree base and height of that triangle, okay? So this here will be your base, and this here will be your height, okay? So let's picture the triangle like if it was standing up. Now, if it undergoes an enlargement of scale factor 2, right, your base will now become what? If your base is 3 here, what will it become? If it enlarged by scale factor 2, it is 3, now it becomes 6. Excellent. So your base, remember, it is enlarging by scale factor 2. So your base would be 3 multiplied by 2, which would be 6, right? And what your height would be? Your height was 2 above, right? Let me just confirm that. Was it 2? Right, what's your height here? From here to here is 2 centimeters. So that 2 centimeters, if we enlarge it by 2, what do we become? 2 by 2 is 4. So your height is 2 multiplied by 2, which is 4. Okay? Now, you can put centimeters because it is centimeters. And we're going to work here now. Area. They ask us the area of a triangle. Let me see who remember what the formula for area of a triangle is. Area of a triangle, my children. No. Base, I had base multiplied by height. Somebody saying it. Over 2. Over 2. Right? All over 2. And these are formulas we're supposed to have. Right? So what we say the base is up there? 6 multiplied by 4 divided by 2. 24 divided by 2 is what? 12 centimeters squared is our area, centimeters squared. Right? Ishan, you good there? You understand this, Ishan? Ishan? Right. 4, 2. Everybody good there? 4, 2. Kaylee, talk to me. That's here. Right? 4, it lines up with 4, and it lines up with 2. X-axis value is always first. Right? Everybody good here? Kiana, you good there?
Yes.
Right? We good. Okay, so this CSEC asking for again. Describe fully the transformation which maps DEF.
So what is this?
This is January 2017. DEF to its image D prime, E prime, F prime, right? So, Giovanni is smiling. You're getting through everything or you're messaging? What is this, guys? What is this? Rotation. Boom. Amanda on stage, right? How are we going to find the center of rotation, right? Now, part of this thing is you could go through the working, but remember, I told you all the working is a lot for rotation, right? It is not a rotation of 180 degrees. We know that. Okay? Now, watch it. If you have to do the working, you actually have to connect the corresponding letters, right? So you connect here. A short 3/4 of us don't have our compass. So you just have to connect two. So we connect this one, and we can probably connect these two, the F's. Everybody good there? Then we have to bisect each line.
So the hell, why?
You have to bisect each line, right? So I'm going back on the construction too to show you all how to bisect the line, right? So hold on. We go in, what on by? It will be bookmarks. It's not here, no, that's all. I feel it on Hold on, Look, I don't see men start a bisect here already. That we talk about. Or did I put it on favorites? Because we did use it last week. I don't know why I didn't save. It's supposed to be here. All right. Let me see if it's here. Edge. I feel it on edge. Nah, it doesn't. It doesn't come up by. All right, look at it. Right, so I'm gonna just remind you all how to bisect, right? So one of the line coming down like this, right? So if you have to bisect that line, you're taking your compass. For those of us that actually come to maths class, right? The rest, you are your compass ending, right? So the compass, you're gonna open it to be on. So you're gauging around where half is. Half is around here, right? So more than half will be about here. Everybody agrees? Okay. Yeah. Lock it in, you make an arc, right? So we go in, boom. That's one arc. You cross where around halfway is. You cross around where halfway is here, right? Take up your compass with the same length. You don't adjust it, right? You're going to make another arc on this side now so that the two arcs intersect, right? And then a line coming through from the top here, passing through the 2 points there would be the line that bisects the given line. Okay? I'll put this in a different color. And if I could change it now, but I don't think so. No. Let's show it. Right. Okay? So that is what we're supposed to do. Let me come back. I come back here now. That's what we're supposed to do here with this bad boy. Right? So when you bisect it, right, Kaylee, when you see you get your compass and you bisect it, I already seen what it would run through. So your bisected line would run through 0, 0. Right? Give me the autocorrect now. All right. So it's looking like it would be like around here. Right. Okay. And I already seen when you bisect the next line, it will be running through there. Right. So I tell you, this thing, yeah, let me be serious about this thing, you know. Otherwise, you ain't gonna make it, you know. So one of the arcs would be here, one of the arcs would be here. That's how the book's supposed to be looking, right? And then when you bisect the next line, it's supposed to cross right there. Come down, man. All right. Okay. Look, both of them supposed to cut here, and these bisecting arcs supposed to look like bow and then bow. Wait. Joel, you there? Joel. Joel. So this will give you your center of rotation as 0, 0, right? That's your center of rotation. Now, in order to find out how much degrees the rotation is, this is what we need to do, right? Rotation is the hardest one. All the reflection, translation, and all that bacchanal is much easier. So watch it. To find out the degree of rotation, you draw a line from here to here, right? And then a line to the corresponding point. How much degrees does it look like? Straight up. How much degrees? Who could tell me? 30, that look like 30 degrees? Nah. Or something.
So I like me even
Look at it. 90 degrees. It's a 90-degree rotation. Okay? So it move from here to here, 90 degrees. Okay? Now, this rotation is something that we have to spend some time on. Right? So I feel I actually want to do over this question next week as the first thing when I come in class next week, right? Okay? Not next week, tomorrow. So that we fresh in our head. Now I had to wrap up there now because I need to go for an appointment. We have 3 more questions. If you all want to attempt it, but I do them tomorrow. Yeah? I want to do over this one tomorrow, right? But this is just an idea, but I will